Okay, pre-calc, we're going to learn about slope fields. Slope fields is another way to solve a differential equation other than separating and integrating. So the first thing we're going to do is we're going to review how to solve a differential equation the way we've been doing it, by separating and integrating. So this is a pretty simple one. We are going to multiply both sides by dx right here to move this to the right, and that's pretty much all we have to do. All right, these cancel, so dy is equal to 2x plus 1 times dx. We multiply both sides by dx. Okay, now we're ready to integrate both sides. Remember, this is what we've been doing. Now, there's still a 1 out front. Don't forget about that. All right, so now we take the antiderivative of 1. The antiderivative of 1 right here is just y. So y is equal to, and remember, when we take the antiderivative, the notation drops out. On the right, the antiderivative of 2x is just 2x to the second over 2. 2x to the second over 2. The antiderivative of 1 right here is just x, and of course plus c. So we're going to simplify that. So we get y is equal to x squared plus x plus c. So that is one way to solve a differential equation. Separate and integrate. Now we are going to use slope fields. But before we can do slope fields, we're going to do this. We're going to go over here and we're going to take our solution. If you notice, our solution right here, I put it right here. And we are going to plug in a bunch of different values for c, because c can represent everything. So when we do that, it looks like this. We have x squared plus x minus 3. And then we have x squared plus x minus 2. And then we have x squared plus x minus 1. And then x squared plus x plus 0, which is just x squared plus x. And then we keep going, x squared plus x plus 1. And then x squared plus x plus 2. And then there's x squared plus x plus 3. All right, so we're going to take all of these different solutions and we're going to graph them on your calculator in the same window. So in y1, y2, y3, y4, y5, y6, and y7. I want you to go to your calculators right now and I want you to punch all of these in the same window, all the way down to y7. Try it right now. No, I'm serious. Pause the video and do it. Come on. Okay, so now what do you guys notice about these 7 parabolas? Well, if we just kind of make a quick graph, it looks like the x-coordinate of each vertex is right about at negative 0.5. All right, so we have just a bunch of parabolas where the vertex, I mean, that's really all I'm trying to get at here. Okay, the vertexes are, the x-coordinates are all the same, and they just move. So there's just a bunch of parabolas, and the vertexes kind of line up there with the x value of negative 5. All right, so you should have 7 of them there already. And so you get the idea. Again, the vertexes kind of all line up here at x is equal to negative 5. Negative 0.5, okay? All right, so there is what it looks like. So I'm just going to put them all in here. They're all there, but you get the idea. There's 7 parabolas, the vertexes line up. All right, so now we're going to go over and we're going to put a slope field in. All right, now a slope field in, we're just drawing in tiny slopes at each of these points. All right, now let's see if I can describe how to do this. All right, this right here, I'm going to highlight it. This dy dx is the same as y prime. That's the same as the derivative. That's the same as the slope. This gives me my slope. So this right here, this equation right here, is what my slope is equal to. So I can punch in points into this equation. Okay, oops, I have a typo right here, you guys. This right here should be dy dx, not y. That's going to confuse you. All right, so let's fix that. This should be dy dx. Okay, so to get my slope, my dash slope, I plug into this. I only have an x here, so I'm only going to be plugging in the x. All right, that's all I need to do. I can't plug in my y because there's no y right here. We're just plugging in the x. Okay, so if I plug in the point 0, 0, I get, again, I'm only plugging in the x, 2 times 0 plus 1. All right, I get a slope of 1. Now, what does a slope of 1 look like? Well, let's review slope down here for a second. Okay, positive slope goes up from left to right. A negative slope goes down to left to right. Let's remember that a horizontal line has a slope of 0. So a slope of 1 would just be a little tiny bit steeper. And a slope of 2 would be steeper yet. The bigger the number, the steeper the slope. A slope of 3 gets steeper. All right, same thing. Negative 1, it's going to go down from left to right and not be very steep at all. Negative 2 would be more steep. And negative 3 would be steeper yet. So what we're doing is we're just putting in little tiny slopes at each of these points. And again, you're just eyeballing them. It isn't going to be perfect. All right, so let's go over here and we'll just put them in as we do them. We're not going to do any more points than what you see on this window. We usually, just to make them small, we just usually go out to 3 in each direction. You can't do any more than that. It's just too tedious. So again, at this point here at 0, 0, when we plug it into our slope equation, we get a slope of 1. So at 0, 0, we just put in a little tiny slope line, and it's not very steep. It's just a slope of 1. So it kind of looks like this. All right? Not very steep at all. Okay, so now we go to the next point. I plug in my x. It's going to be the same. 2 times my x of 0 plus 1 gives me a slope of 1. So you can see at this point here at 0, 1, my slope is 1. So I just put in a little tiny slope. Now, you can see, because in this equation I'm only plugging in my x, whenever x is the same along that column, they're all going to be the same. If I plug in the point 0, 2, I'm going to get a slope of 1. And if I plug in the point 0, 3, every time I plug in an x value is 0 all along this line, those slopes are all going to be 1. So that's something that helps us when we make a slope field, is we look for patterns so that we can make our work easier, work smarter, not harder. Okay, let's go to a different x value. All right, let's go out here to 1, 0. Let's plug in this point. Again, I plug in 1 for x. So I have 2 times 1 plus 1. Well, that gives me a slope of positive 3. So that's going to be, the slope here is going to be a little bit steeper than this slope of 1. So we're just eyeballing it. It's not going to be perfect, but it should be steeper. There's my slope of about 3. And again, because we're only plugging in x, it's going to be the same. All right, let's do this one. Let's go out to negative 1, 0. Let's plug it in. I only plug in my x. 2 times negative 1 plus 1 gives me negative 1. So my slope here is going to be negative 1. It should be exactly the same steepness as this, but going in the other direction. So it kind of is going to look like this. And again, the column in this particular one, they're going to be the same. Slopes of negative 1. All right, it doesn't have to be perfect. We're just eyeballing it. Okay, let's go out to negative 2 right here. Negative 2, 0. 2 times negative 2 plus 1. Well, that gives me negative 3. So this line, this slope here in this column is going to be negative 3. It should be the same as this column, but negative. So a little bit steeper than these negative 1s right here. So this column is going to be negative 3s. So a little bit steeper. Again, it doesn't have to be perfect. This is pretty tedious. All right, let's do a couple more just to see what happens. Let's go out here to 2, 0. So we're going to plug in 2 times 2 plus 1. That gives us a slope of positive 5. So out here we need a slope of positive 5. It's going to be even steeper than this slope at 3. So I'm going to make them really steep. All right. And again, you're just eyeballing it. All right, and then last, the one we're going to do is we're going to go out here to negative 3, 0. I plug in 2 times negative 3 plus 1. Well, that gives me a slope of negative 5. So here, at the point negative 3, 0, my slope is negative 5. It should be steeper than this slope at negative 3. So we just put them in. Those are going to be pretty darn steep. And again, the column is all the same because we're only plugging in x here. So now what we do is we follow the slope lines and we try to put in solutions that way. And you can kind of tell if we follow it, that looks like a parabola. And if we follow this, that looks like a parabola. And then we can kind of follow, we just follow the slope field. You kind of see how it curves. You can see there's a bunch of parabolas in here. And that's not perfect, but you get the idea. I should draw that one again. There we go. And kind of draw this one. It's not going to be perfect. You're just eyeballing it. But again, these parabolas right here should be exactly the same as these parabolas up here. This is a bunch of solutions to this differential equation. This is a set of solutions, and this slope field gives us a set of solutions. You can kind of see my vertexes all lined up. The x value is negative 0.5 here. Hey, they all line up here too. This slope field should look very similar to this. All right, so slope field is just another way to get a set of solutions for a differential equation. Now this particular example, hey, it was way easier to separate and integrate and pick values for c and graph the parabolas. This was a much more tedious way, but there are some differential equations where, believe it or not, this is a much easier way to get a general set of solutions. So I hope that you can see the similarity between the two ways we do it. All right, pre-calc, go for it. Slope fields, see what you can do. Take care.